Welcome, YouTube and makers, and thank you for joining me today on our build. Today, we're going to cover one of the fundamental skills required in making our 3/4 inch scale Pennsylvania A3040 switcher steam locomotive engine. And that skill is filing. So to demonstrate, I'm going to be showing some real basic principles on this aluminum plate that I'm going to be using for the base for my lathe. For my lathe, which you can check out in the links below, the manufacturer recommends using a wood board that's readily available at your local home supply store and putting rubber feet in the corners. They do this because the manufacturer wants to keep their tools and their machines light, readily transportable, so you can take them out, use them in your space, and then put them back someplace safe. Me personally, I prefer the look of a nice beefy aluminum plate, as well as the ability for me to be able to kind of attach it to, move it, and mount it to any surface I needed to, and the rigidity, additional rigidity it would provide. Though, keep in mind this is going to add a lot of weight to my lathe and make it a little less transportable, but I'm fine with that. At my local metal supplier, I found a couple of really great aluminum plates. Though this one is a little bit more banged up, but for rem and drop prices, it was a really good deal. Be sure to stick around to the end because we're going to have a tip from our Journeyman. First off, why are we going to deburr? And why are we going to be doing it to raw material before and after our machining operations? Seems kind of tedious, right? And if we're just going to end up machining off all the surfaces to make this really great, fantastic part, it's part of our make that's going to be going in outer space and flying on the space shuttle, why bother deburring? Well, the simplest explanation, and on the lower level for our introductory course, is that while burrs are small and may seem insignificant, you'll be locating on a burr when you mount it into your chuck, collet, or vise. And when you do that, when you don't remove the burr and you put it into your holding device, you actually kick out your raw material or part, and it's going to leave it in there at an angle. Though small, that angle will impact your machining operation. On our finished parts, we also want to deburr them because the different machining operations will impart a razor sharp edge to our parts, and we want to make sure that they're safe in handle, and if additional machining operations are required, that burr is removed to keep things all nice, square, parallel, and perpendicular on our locating surfaces. On this plate, I'm going to be deburring in order to smooth off and remove the burrs, and also filing the top surface to remove any imperfections. And I'm going to leave a little bit of a radius edge on it. Now, I'm going to be leaving though these bandsaw marks on because it gives the edges of this place a unique look, and since I'm not going to be locating off the edges of this plate, I'm not as concerned about the impact on parallelism or perpendicularity of the sides because they're not going to be used for locating. Though, if you are going to use the edges for locating, you'll want to make sure that you true up and square the edges and that they're machined. Here, I've already got the plate clamped down to the edge of my workbench, and I can get at the burrs at whatever angle I need to. Today, I'm going to be using Nicholson files, and links to this tool as well as any other tool you see here today is available below. Files cut only in one direction. You don't want to be Gomez and file like a nut job back and forth without removing your tool. So we're going to begin by taking our file card and cleaning our file. I'm going to do this often, before I begin filing, while I'm filing, and when I'm done filing. The reason why we're going to do this is because a buildup of material affects the cutting action and can potentially scratch the material that we're filing and deburring, kind of defeating the purpose. So, to file, I'm going to begin filing at a 45-degree angle. Okay. Move the file in the direction of the cutting action. I'm really not applying a lot of pressure, not much more than the actual weight of the file. Okay. I'm going to file in the cutting direction, lift it, move it to the next cutting position, lower it, and file in the direction of the cutting action, lift it, move it to the next cutting position, lower it, and file. Lift it, move it to the next cutting position, lower it, and file. You're going to continue filing the entire length of this side and around the circumference of the object you're working on. And I'm going to do this on both sides of the plate. And throughout my filing sessions, I'm going to stop and feel this edge frequently. And I'm going to also take a good look at it and get down and kind of look at it on this plane so that I can see that I've got the edge that I'm looking for and that I like. Here, I'm going to be very, very light, little more than the weight of the file, because this is 60-61 aluminum plate, and too much pressure is going to induce chatter, and it's going to leave a rough edge. Though, if you do apply too much pressure and you induce chatter, you can take a piece of sandpaper and sand down the edge. Just like with any other sanding, you'll want to start with a coarser paper and work your way up to a finer grit. So here I'm going to start with 120 and work my way up to 600. Or you could stop wherever you find that the texture left behind is suitable for your needs, or just plain out appealing. I'm going to angle my file at a very low angle, perhaps 10 or 15 degrees. And the reason why I'm doing this is that after initially filing at 45 degrees and satisfactorily removing the burr and getting an edge that I like, I desired a little bit different angle to these corners. You'll notice that while I'm filing, not only I'm not just filing up and down, but I'm filing at a slight diagonal. And with the softness of this aluminum plate, I found that action removes a better amount of material than just straight up and down. So you'll want to experiment a little bit on your plates and whatever project you're working on to kind of find what works best for you. Now remember, if you're going to do the 15-degree acute, you have to do this plane as well as this plane. So, as before, we're going to file in the cutting direction, lift. Now here I'm going to do a little bit of overlap, bring it down, and file. Lift, a little bit of overlap, bring it down, and file. Lift, a little bit of overlap, bring it down, and file. Lift, a little bit of overlap, bring it down, and file. Keeping it at that really low or acute 10 or 15 degrees. A little bit of overlap, and file. A little bit of overlap, and file. That's good. I like that. And we're going to do this again, that operation, for the entire circumference of the plate on both sides, at least for my purposes. If you desire a little more of a radius edge, you're going to also file, as we have before, but you're just going to roll your file over that corner. And you can vary how quickly or how much you roll to either do a perfect quarter circle or a little bit more of an oblong shaped or a quarter of an egg shape. You'll have to kind of experiment and play around to see what works best with your material and what imparts the finish that you're looking for. I am going to be running the file flat against this plate. As you can see in some of the close-up, there are some scratches and gouges, as well as little dings in the surface of the plate. Oh, here's one that you can really feel and are a bit prominent. That's going to be a little bit of a problem for me, because since I'm going to be, this is going to be on the undersurface of my lathe plate, these damaged areas may not allow the plate to sit flat and squarely against whatever mounting surface. So I'm going to take my file, place it down flat against it. I'm going to ensure that I am applying even pressure to the file and file the plate. And I'm going to lift, bring it to the next area, and bring it down, and file, and lift. Now we're going to have to work around these clamps, and once you're done, you can move or reposition the clamps and make sure, and don't forget to hit those areas. Bring it down, file, and lift, bring it to the next area, place the file down, file, and lift, bring it down, place even pressure, file, and lift, bring it to the next area, bring it down, file, and lift. I'm going to continue to run the file flat across the entire surface and then bring it back and run it across the entire surface again, sometimes varying the angle, like here at about a 45-degree angle. So same thing, bring the file down, file, lift, reposition, and file, lift, reposition, and file, lift, reposition, and bring it down, and file. You'll notice that very quickly a lot of material builds up on your file, and you're just going to have to clean more often. Now then, there is only some way we could get away with a little bit more filing. Well, there is, and that brings us to our Journeyman's trick. So, the trick of the Journeyman is to first thoroughly clean our file. You're always going to have to clean a little bit. Once our file is clean, we're going to take something like, say, a piece of chalk or a welder's grease pen and run it across this surface. And it's going to leave behind some chalk or welder's grease on your file. This does a couple things. One, it's going to allow the filings to be ejected out a little bit better from the file, but also acts as sort of a lubricant. And depending on the condition of your file and the material you're filing, these filings are not going to build up quite as quickly, and you can go in a little bit further in between cleanings. If you look closely, particularly to this area here, there is quite a gouge, and then there is a pretty good one right here. So what can we do about those particular areas and focusing on those? We're going to do something called feathering, where basically from the damaged area we're going to file, lift, turn, and radiate out from that damaged area. File, lift, turn, and just continue to radiate out from that damaged area. Lift, turn, bring it down, file evenly, applying pressure, bring it down. After turning it, file, lift, turn, bring it down, file, lift, turn, bring it down, file, lift, turn, bring it down, and file. That's much better. And we're going to continue to do that until we're satisfied that the particular damaged area has been knocked down. Now, be careful when doing that. You don't want to overdo it. Otherwise, you may leave a depression in the surface of the material you're working on. Thanks for watching, and now that we have the basics of filing down, we can prepare our raw material for our different machining operations. And this will help ensure that everything sits a little bit more perpendicular and parallel when mounted in our vices, our chucks, and collets. Be sure to hit that thumbs up and like and subscribe to my videos for more parts of the build as well as tips and techniques. And please be sure to leave a comment below. I'd love to hear from you, especially to hear some of your advice. If you have a journeyman's tip, we'd love to hear from you, and we'd love to feature it on our channel and as part of our mate. Till next time, good luck, stay healthy, have fun, and keep making chips.